Hi, today I will be explaining the trends in the periodic table. This video will include atomic radius, ionization energy, electronegativity, electron affinity, metallic trends, and how all these trends are affected by the shielding effect, effective nuclear charge, and Coulomb's law. So I will start off by explaining the shielding effect, effective nuclear charge, and Coulomb's law so that you will be aware of these words during the video because they are very important and they will be used to explain most of the trends. So let's start off with Coulomb's law. Coulomb's law is a law that states that the strength of the interaction between two electrical charges depends on the magnitude of the change and the distance between them. So the equation says F, which is force, is equal to K, which is a constant, and then K1 times K2, which are the charges of the atoms, over R squared, in which R is the distance between both atoms. Second is the effective nuclear charge. So effective nuclear charge is it might be easy to understand it in a hydrogen atom, but since only the force of attraction between the nucleus and its only valence electron is present, so that's the reason. Well, in the many electron atoms, it's not that easy. In addition to the attraction between the electrons and the nucleus, there is an opposite force of repulsion between this electron and the other electrons in the atom. So it's basically the net attraction that is the result of the nuclear attraction decreased by the electron-electron repulsion. This partially screened nuclear charge is the effective nuclear charge. Finally, the shielding effect. So the shielding effect in which electrons in the atom shield each other from the pull of the nucleus. The shielding effect describes the decrease in attraction between an electron and the nucleus in any atom with more than one electron shell. The more electron shells are there, the greater the shielding effect experienced by the outermost electrons. So let's start off with the first trend, atomic radius. There are two major trends in the atomic radius, which are, within each group, bonding atomic radius increases from top to bottom. This trend mainly results from the increase of n, or the principal quantum number, which means that as you go down, electrons have a higher probability of being farther from the nucleus, which increases the atomic radius. The second trend states that within each period, bonding atomic radius decreases from left to right, except for some exceptions, such as from Cl to Ar and As to Se. The main factor contributing to this trend is effective nuclear charge. The increasing nuclear charge causes valence electrons to be held closer to the nucleus, which causes its bonding radius to decrease. The second trend is ionic radius. The size of an ion depends on its nuclear charge, number of electrons it possesses, and the orbital in which valence electrons reside. Ionic radius increases as you go more down a group. As you move down a group, you are adding a new shell to the principal quantum number, which will cause an increase in the radius of the ion. Ionic radius also decreases for metals from left to right, as metals lose their outer electron orbitals and become all isoelectric, which means that they will all have the same number of electrons. In these cases, the ion with the greatest amount of protons is considered to be the smallest. For nonmetals, the ionic radius increases from left to right, since the effective nuclear charge decreases due to the number of electrons exceeding the number of protons. Ionization energy. Ionization energy of an atom or ion is the minimum energy required to remove an electron from the ground state of the isolated gaseous atom or ion. Trends in the ionization energy are as follows. Ionization energy generally increases as we move across a period. Alkali metals need the least ionization energy and noble gases show the highest. Some exceptions include group 16, because of the repulsion of paired electrons in the p4 configuration. Ionization energy generally decreases as we move down any column in the periodic table, which occurs because of electron shielding. Further, electrons in higher energy levels are more loosely held to the nucleus, so we need less energy to remove it from the atom. Electron affinity. Electron affinity is the energy change that occurs when an electron is added to a gaseous atom. Electron affinity decreases as we move down the group. The greater the distance, the less the attraction, and this is why whenever we go down, electron affinity always decreases. Electron affinity increases from left to right because when we have more electrons in the valence shell, they become closer to the nucleus, which means a stronger attraction between the nucleus and its electrons. Group 5 has its own story, and thus it is an exception. Because elements have half-filled p subshells, the added electron must be put in an orbital that is already occupied, which means more electron-electron repulsion, which will cause it to be more unstable. So this results in either positive or less negative electron affinity. Electronegativity. Electronegativity measures an atom's tendency to attract and form bonds with electrons. Electronegativity increases as you move from left to right across the table. This is because if the valence shell is half full, it will require less energy to lose an electron than it is to gain one. Conversely, it is easier to pull an electron into the valence shell than it is to donate it for ones which have more than half full shells. Electronegativity decreases as you move down a group because of electron shielding. Electron shielding causes the attraction force to lessen, which will make the atom less electronegative. Exceptions include noble gases which have a complete valence shell, and lanthanides and actinides which do not follow any trends. Okay, finally to the last trend, metallic trend. The more an element exhibits the physical and chemical properties of metals, the greater its metallic character. So there are some characteristic properties of metals, such as having a shiny luster, sometimes with various colors, although mostly are silver. Second, solids are malleable and ductile. Third, they're good conductors of heat and electricity. Fourth, most metal oxides are ionic solids that are basic. And lastly, they tend to form cations in aqueous solutions. So you might be thinking, okay, how can I determine this? So I'll give you this. Another definition for metallic character can be how readily an atom can lose its electrons. So metallic character decreases as you move from left to right, because you will have more valence electrons, which will make the element less reactive. Metallic character also increases going down because of electron shielding, which makes electrons in the valence shell more loose, which will make elements more reactive. Thank you.